Chapter 24 Spells, Buffs Part 1. Earlier, we made a progression of gradually more difficult monsters, in essence by just increasing their hit points and the damage they hit for. We hinted we'd later add more variety to them. That time has now come. There are infinite ways to give them variety, mainly by varying their behavior. Our approach here will be to add spells and magical effects to the game, and allow the mobs to cast these spells. At some later point, we will also give the player access to the spells. Intention. The initial spells will be similar kinds of limited duration state changes, which will differ in their effects. This type of spell is sometimes called a buff or a debuff, a damage over time, a dot, or a duration effect. We'll use the term buffs for all such effects, even though technically debuffs connote negative effects, whereas buffs imply positive effects. The kinds of spells we've seen so far, really the commands or actions, have been one-time effects. Our combat attack was such a one-time effect. Just imagine it was named Magic Blast instead of Weapon Hit. A buff is distinguished by instead being a lasting effect. Normally, it has a limited duration, for example for the next 15 turns or a 10% chance to wear off each turn. But it might even be permanent, maybe a disease or a cursed weapon, which persists until you find an antidote. Buffs represent a, most often temporary, change of state. As buffs are often negative effects, limitless durations are unpleasant, short-lived durations are preferable, and ways to clear or remove debuffs are welcome. To give a taste of what debuffs are about, have a look at this enumeration collection of buff effects. The file 24 buff enumeration will contain the buff enumeration, with states like these: confuse, afraid, rude, blind, paralyze, slow, freeze, petrify, burn, poison, choke, shock, charm, sleep, stun, bleed, silence, disarm, levitate. In this chapter, we focus on getting the basic buff mechanism in place. So we'll not address all of these straight away, we'll just start with a few of them. The plan. We'll need mechanisms in the monster AIs that will attempt to cast spells. We'll need a buff command to cast the buffs. And as buffs are distinguished by enduring across multiple turns, we'll have a structure to track each single active buff, the buff interface. We'll need a place to store those buff trackers. This will be in the mobs themselves. We'll outfit each mob with a container holding its active buffs. That will be the active buffs class. We must do the actual life cycle tracking of the active buffs. We'll do so as we process the turn for each mob at the end of his turn. We may have to message notify the player about important buff effects, like "You are hurt by the poison for 7 damage." We'll also want a kind of head-up display panel to visibly highlight current buffs on the player. Finally, we must implement the actual effects for at least one buff. So to recap, NPCs will cast spells, a buff command. The buff command will add a buff interface to the target's active buffs. The normal turns processing will do updates on those active buffs. Any buffs active on the player will be visible in the head-up display. And various subsystems of the game will independently react whenever a creature is affected by a given buff, for example making the creature stumble or take damage from poison. Making the AIs use spells. We start with the AI. Let's try to make our mobs cast spells. Our mobs in this regard is really the Wake AI running our Moody Bats from chapter 18. So we'll clone 18 Wake AI into 24 Spell AI. We then modify the turn method and the constructor. The change to turn is that the mob will try maybe cast spell when doing its turn. The spell AI constructor gets a spell rate saying how often the monster casts a spell. Of course, we don't yet know what maybe cast a spell will actually do. So far, the spell AI will look like this. To get this AI into the game, we will add this line to the mood AI. So we'll clone the 23 builder 2L into 24 builder 2M and change make AI to this. And that in turn requires a launcher index24 spells TS that looks like this. But that method may be cast spell. What should it do? Well, we must decide if we want to cast a spell, and if so, pick a spell type, and then execute a spell command with that type. The mob AI should decide to use a spell, possibly every random third move, possibly more or less often depending on how close the player is. It should then pick a random buff type from the buff enumeration by some strategy, for example the mob zone level, or in range of mob zone level. And finally, we'll execute a buff command, which we don't have yet, with the chosen buff enumeration value. So maybe cast spell will look something like this. The method pickBuff should probably use the me monster's level or properties or the random number generator to pick a spell type. But just to get started, we can cheat with this very basic buff picker that just always picks the buff Confuse. Visibility. There is an issue with how monster spellcasting currently would work. Any awake monster anywhere on the level can currently cast spells to attack the player. There might be insanely all-powerful monsters somewhere in the universe, but this level of adversity was not what we had in mind for our player here. A more reasonable level would be that monsters can only attack you if they can see you. We'll therefore include our earlier can see check from the Better Bad chapter. With this, the first lines of maybe cast spell now becomes this. The buff cast command. And then we'll need to implement that method cast for the spell. It could look something like this. And this then requires us to implement the buff command. It should put the buff on the target mob, so we can track which buffs are currently on the mob. It will cast its own method, or call its own method add buff to mob, which we again don't have yet. The bookkeeping for buff tracking. To get going, we'll need that structure to hold data to track an active buff. It should know things like which buff type it is, how long the buff will still be active, and any dynamic effect involved in the buff, that is poisoning or bleeding or something. So we make 24 buff interface, which contains these bits. And the tick interface listed there is for dynamic effects later. Now the actual command. With this, we can now implement 24 buff command, like this. Beware that the poison tick above is not yet accounted for. We'll get to that in a bit below. Storing the buffs on the mob. The add buff to mob should add the buff interface to the target mob somehow. So we'll need that kind of active buff container on the mob class to track its active buffs. We'll make a class active buffs, which will be a container of buff interfaces, and it will have some sort of add method. We'll then put an active buffs member on each mob, so behold the 24 active buffs.ts. And we will insert such an active buffs property into the class mob this way. All this now allows us to implement the add buff to mob method, simply like this. The mob buffs lifecycle. Getting the active buffs onto the mobs is only half the story though. We have to manage their lifecycle so they don't remain on the mobs for longer than they should. Specifically, they should only remain there for buff interface.time number of turns. To aid us with this, we give the active buffs class a ticks method, which for each active buff will decrement its buff countdown and remove the buff when it's done. Notably, it will also execute any associated tick effects of the buff. So who's going to call that ticks method? We must do so in the NPC turns loop. we'll have to do it separately for the player and for the NPCs. The best place to do it is after a turn, the same way we currently handle auto-heal. This way, any effects it causes will be displayed along with the other stuff that happens as part of the turn the player just did. Just imagine if we instead executed the buff ticks just before the player would input his turn. That would mean that while you were pondering what action to take next, it would be with the threat of, but actually something may already have happened to you which you haven't been told about yet. For example, that you are now poisoned. Clearly, we want to apply the buff ticks in a manner which allows us to report any effects to the player before we pass the initiative back to him. To incorporate ticks, we now modify 09 base screen with the following bits. Buffs on the dashboard. We also need a way to let the player sense what is going on. For the monsters, we'll not tell him every single thing that happens with debuffs, only whenever a debuff is applied to a monster. The org is confused. For the player's buffs, we'll give him more details. We want a head-up display status panel telling the player which debuffs currently affect him, and the remaining countdown timers. That is status labels like 5 confused. To achieve this, we extend class draw map with the methods render buffs, which we'll call at the end of render stats. With this, we should see a list of current afflictions at the bottom of the dashboard. Our enemy monsters can now cast debuffs on us, and these will show up and count down in our game display. The effects of confusion. However, being afflicted with our single confused debuff will not yet do anything, so we need to implement a behavior for being confused. Stay tuned for chapter 25.